Hello. In the previous tutorials, we got familiar with bar graphs and pie graphs and LS HMI. Today's lesson is about the meter graph. We're in the XP Builder software environment, and to use the meter graph, we need to click on this section. After clicking, wherever we click in the software environment, the meter graph will be placed there for us. So for example, I click here and we can see the meter graph here. If I click on the meter graph itself, a window will open for us. The first tab is basic, similar to the previous graphs I explained to you. Here it has a device section. If I click here, a window will open for us. This top section is the controller. We have connected our setup to a compact LS PLC of the XE type. In this section, we can select any of these options. For example, I select MW, and here we can, first, let's go ahead and assign a specific value to MW. For this example, I'm going to select MW10 right here. Now, you'll notice that this setup is very similar to the bar graph configuration we thoroughly explained in our previous tutorials. We have the ability to manually set its specific upper and lower limits to fit our needs, and there are actually two different ways to accomplish this task effectively. There's a constant section, meaning the upper and lower limits are set as fixed values. By default, it's set from 0 to 100, but we can change its value using this section. And there's also a device section where you can define two memories for it. The minimum and maximum of that graph, or its lower and upper limits, can be read from those two memories and changed accordingly. For example, we can set the minimum part for it. If I click here, we can, for example, define an MW, for instance. We set MW0 for the minimum, and the MW1 setting is now at the absolute maximum level. All right, now that we have that set, let's test both of these parts together, both the constant part and the device part. For now, I'll set it to the constant part, which is the default setting. Now, if we click on display, we can change the shape of the chart here. Here it's set to default. Our chart here is in the shape of a circle. But we can, for example, transform the shape into something like a half circle, or we can adjust its overall orientation and positioning as well. The specific direction of the half circle can have a variety of distinct and unique modes. And as you can clearly see here, when I change this setting, we can consider various different options. That means we can carefully consider each of these individual modes separately, going through them one by one to see the results. Okay, so now I'll set it as a half circle and we'll test it together in this case. We can also change the color of this half circle section itself. For example, we can make its color red, or we can also change the color inside it. And in the same way, this pointer you see here, it's color too. This pointer is also customizable for us. And with this section, we can even change the direction the pointer moves. By default, it moves in the direction of the clock hands. But if we want it to move counterclockwise, we can do that too. If we select this, it will move counterclockwise. And in this section, there's also a scale that sets the scale for the top of the chart. For example, if I choose 6 here, it will divide it into 6 sections. We can also change the color of these scales themselves. We can change it. So, for example, you can pick any color you like here. For example, I'll choose white as the color. And you can see that now we have 6 scales here. We can also work with each one of them. We can also assign a specific numerical value to each of these individual divisions as well. This is done so that when we are carefully looking at this detailed graph within our main dashboard interface, we can see and interpret all of the specific values much more precisely and clearly than before. If I click on this section and select text, here we can assign a value to each of these scales that are shown here. I'm going to select the font as Tahoma, set the size to 24, and keep the color white. Now here we can set its value to 0. And in the same way, if I copy this one, we can set this one to 20. I think we can adjust this specific one to 40. We can set this one to 60. This one to 80. And then finally, we have the very last scale here, which we can go ahead and set all the way up to 100%. So here it's divided between 0 and 100. We've divided it up here. Now, for the purpose of testing this specific chart, when we go ahead and connect this HMI to a device like a PLC, we need to remember that we previously set the internal device address to MW10. It reads this MW10 from the PLC, and based on the changes inside it, this needle here moves. For example, let's say you have a temperature value, or you're reading a pressure value, or maybe you have a weight value. You read it, and if you want to display it on the HMI, when, for example, the temperature changes, this needle also changes for you in an analog way, and with the temperature changes, this needle moves for you, and you can see the temperature on the HMI. All right, now here, since we want to test this together in the simulator environment, I'm going to use a numeric input. So in this section, I'm going to place a numeric input here. I'll set its address to MW10. I'm setting it now. Here, I'm entering the number 10. And in the text section, now the format of that display, we can also change the size of the numbers so it looks better for us, and center it as well. Now we can test this together. If I enter the simulator environment, here, for example, I enter a number. For instance, if I enter the number 20, you can see that the pointer moves to 20. If I enter 40, the pointer moves to 40. If I enter, say, 55, the pointer goes between 40 and 60. If I enter 90, it works the same way. And finally, if I manually type in the specific value of 100, you will clearly observe that the pointer is now accurately positioned at the mark of 100 for us. So, as you might expect, this pointer can move smoothly and precisely anywhere between the range of 0 and 100. Well, this was for the case where the minimum and maximum values of our chart were between 0 and 100. As I explained to you, we said that we can also set the minimum and maximum values. We can change them using two memory slots. For example, MW0 can be for the minimum and MW1 for the maximum. All right, now we can delete these because we don't need them anymore. Okay, I'm going to copy from this. One for the lower limit and one for the upper limit. All right, I'm going to click on this part. We'll set this one for the maximum value. Our maximum was MW1. So here, I'll enter MW1, and here as well. I'll enter MW0 for the lower limit. All right, here too, we enter MW0 for the lower limit. So this one is MW1 and this one is MW0. Now let's go ahead and use some text as well. I'll just click right here on the text tool, and then I'll carefully place it right over here in this spot. I'll write upper on this one. For the upper limit, I'll select its font as Tahoma. I'll set the size to 26 and keep the color white as it is. So this will be for the maximum. I'll copy it from here. And I'll create a separate one for the minimum in addition to that. All right, now let's go into the simulator environment of the software and test this together. Okay, we'll leave the lower limit at 0. Let's see. Now, looking at the upper limit setting for this specific parameter, let's go ahead and use a practical example where we will manually enter the value of 50 into the field. What this effectively means for our configuration is that the system will now operate within a defined range between 0 and 50. Okay, so this is how we establish those boundaries, and these are the specific steps we need to follow for this part of the process. When you take a close look at these specific idles right here, you'll begin to notice that these are exactly the things we've been discussing for quite some time now, and it is truly remarkable to see these unique objects presented in such a clear and distinct manner for everyone to observe and appreciate today. Finally, if I enter the number 50, the needle will be at the maximum, like this. As a result, this value has the ability to fluctuate anywhere between 0 and 50. In the same way, we can set the lower limit value and the upper limit that we have in mind. We can enter them here, and based on the memory we read, this chart will change for us. Thank you very much for your attention.